Picture this: you're rushing into a building, you press the elevator button and it lights up, ready to whisk you safely up or down. But have you ever stopped to wonder, with millions of presses every day, why elevator buttons almost never fail? What actually happens the moment you press that button, and what keeps it working reliably, year after year? The story of the elevator button is a tale of invisible design, where engineering quietly outsmarts failure. When you press it, you're not just completing a circuit, you're tapping into a world of redundancy. The button itself is built to handle abuse. It's tested for tens of thousands of presses, using robust materials like stainless steel or tough plastics. But the real magic is underneath. Inside, most elevator buttons use what's called a momentary switch. Think of it as a tiny metal dome that snaps down and bounces back, making and breaking contact in a split second. This design minimizes wear and tear, but it also means that even if the dome loses its spring, backup mechanisms are ready. Elevator buttons are often duplicated in the circuit. Pressing one triggers multiple paths to the control system. If one path fails, the others take over. The lighting indicator? It's powered by a separate circuit, ensuring the button's feedback never depends on just one component. Even the wiring is doubled up in high-traffic elevators, so a broken wire isn't the end of the story. And it doesn't stop there. Elevators themselves monitor button health. Modern systems log every button press and can flag strange patterns, like a button that sticks or sends no signal. If the system senses a potential failure, maintenance teams get alerts, often before riders even notice. Why this obsession with reliability? Because the stakes are high. Elevator failure isn't just an inconvenience, it can be a safety issue. So, engineers build in layers of protection. Physical design, electrical redundancy, and digital monitoring all combine to guard against disaster. Even the act of pressing is considered. Tactile feedback is carefully tuned so you know the press worked. It's not just about satisfaction, it's about trust. You need to feel confident every single time. Every element is overbuilt for durability. Stainless steel resists corrosion, sealed switches protect against dust and spills. And the buttons are tested with simulated fingers, presses, even with impacts, to ensure nothing slips by. If you've ever seen a button that doesn't work, odds are, it's not the button's fault. Usually, it's a software lockout or maintenance in progress. The hardware rarely fails, because it's designed not to. So, next time you step into an elevator, remember, you're touching the result of decades of engineering, all focused on one goal, making sure your journey starts with a button that never breaks. Follow Lorelight for more stories worth knowing.